Hi, I'm Suhyung from Technical University of Munich. I'm currently a postdoc at the Geometric Institute, also a chair of computing and civil and building engineering, both directed by Professor André Borrmann. Today, I would like to talk about some um, looking back into the past of the space layout generation. So, which I consider the first paper on this topic, the general space planner. I wonder if many of you probably have heard about this. And then to what has been changing until recently, the learning capability of neural networks that we have nowadays. So the original title was a systematic mapping study, which it was a review, but then I had to remove study out of it because of the limited title of the EC3 formatting. So it's a review paper. So what I mean by the learning base, I mean, thanks to Mikhail and also Han, who already presented our work quite related to this. Like, I mean, learning by deep learning, which if you want a computer to be trained to classify this image to be three, first we need encoding, which is computer readable and trainable, and then model architecture that is appropriate to process the represented encoding. And then the last is the training process, which also involves loss function design, which is giving the guidance of what we want to optimize throughout the process, right? So I consider these three to be a core components of deep learning. And using this deep learning, many researchers like really extensively have explored proposing the way to generate this space layout, including generative adversarial networks and vision transformers and diffusion models. Not only that, I had a chance to look into how neural networks has been adopted in architecture design, which I found that generating building layout has been the most extensive study, the topic that most extensive studies has been conducted. And we already seen a lot of progress already today, as I mentioned. So I was then curious, when did people start doing this, right? Then I found a paper called General Space Planner. Has any of you here heard about this paper? I'm pretty sure at least few. Oh yeah, I mean it's more than what I expected, because this paper is actually from 1970s, which was first presented by Professor Chuck Eastman, who is also known to be a father of BIM. And just to give some time to think about, imagine how the system would look like. I'll give you some description about the general space planner just from the original description from the paper. So first, general space planner, in short GSP, is an interactive design system that the designer uses the operations to generate arrangements according to one's specifications and manually calls the relations to evaluate. Second, GSP is a space packing system. The system arranges objects in a space such that all are located in a non-overlapping arrangement. And the last, GSP is an automated design system. Here, the location operators, objects, and constraints are automatically called by the problem-solving routines. So I believe all of you have a different imagination about it, but of course, for the presentation, I had to give it to GPT without telling them it's something about GSP. So this was the image that I got from the description. I didn't do a multi-step, but it was the first image that I got from it. And then it is quite similar to what we would imagine now, right? I mean, we also have seen quite similar system already today, which I was quite surprised to see how the original figures that was included in the paper from 50 years ago. So in the original paper of GSP, there was already consideration human-computer interaction and then how to promote the collaboration environment. And then not only that, using explicit design conditions and while complying to multiple requirements to get the automated generated building space layout. So for me, it was really interesting to read through this paper, and I brought up how the procedure was defined in the original paper. But maybe I'll just like explain the core components again. Um, so like a core components of GSP includes 5 components of space, which is a design space, and a dwelling unit, which you can consider as a single space unit. And then spatial relationship, which becomes a constraint between the spaces. And also the operator, as defined earlier, is an operation that you could do with the dwelling unit to place them in the design space. The last is a initial design condition, which we called it optional. So like it's like even in the given design space, you could have some initial design options. But then to help you out understanding like what it means by this, maybe like a visualization would be easier. Here comes the like initial space and design space, which we are placing this dwelling unit, and the even the space relationship as a constraint. We are operating, so we are placing this space one by one until we find the option that satisfies the full constraint. So I thought it was quite amazing because it's quite close to the system that we would easily imagine using AI, but it has been like out there from when we started having personal computers, maybe not even like before, right? So what I did basically was mapping these 5 core components of GSP against 3 core components of deep learning, machine learning, encoding, loss, and modular architecture. So I was looking into how the digital representation and the objectives for generation and the technique to control the design options has been changed throughout this 50 years. But I'm not going to introduce like what has happened during all this period. But then, the paper does cover it by the decades. But today, I'm just going to talk about dividing into 2 different steps of like before neural networks and after. And also, I'll just introduce some of the findings that I learned from looking into these papers, focusing on what has been consistently important throughout 50 years, and then what has changed with the emergence of the neural network application in its domain, and what remains to be solved, I see. So it's my interpretation how we can continue our research. So first, in terms of representation, what remained consistently important, as we already seen today as well from Hannah's presentation, the graph, which represents this relationship, and vector, which is robust to be converted into a design option that's playable, has remained consistently important throughout the period. Which, of course, with the emergence of the neural network, which has a capability of neural inferencing to generate the flexible shape of space layout, and also represent those implicit design understanding that's learned from the training, has emerged. And I see like a future direction, of course, will be because this vector and graph has its own benefit of having the robustness, not only for generation, but for the checking. But then image also has not only image, but this kind of neural represented design has its own value for having this flexibility also, including those implicit design intents should be something could be a future direction in terms of digital representation. And control, I mean, control by like how do we generate them, right? So also what I found out, I mean, of course, because I compared them against before neural network and after, there's a diverging trend between learning-based and operation-based. But then what still remains to be continuous was a parametric-based integration. So it's not only about generating the design option, but it's really like to get them included in the design workflow, right? And what has been different, of course, it's because I divided this step by like before and after neural network. There has been like a learning-based approach quite recently extensively. And then, what could be the future direction? I believe it is quite close to what has been consistently important, because at the end, what you want is not a generator that's just standalone, but really get this integrated into the ongoing design practice and the work, and get them integrated in the workflow, right? And the objectives. So, what has been mainly focused was that the like a given constraint in terms of the spatial relationship, mostly related to the adjacency and connectivity between the rooms and the certain scale that's given as like conditions. But then, as time goes, I mean, like today we also saw a really good example of how constructability could be considered during the design, right? So the objectives also has been diversified as time goes, especially with the emergence of neural networks. So I believe the next step forward is actually like having this representation and the control technique that can cover these diverse objectives, which is also increasing as we require more things in design, like carbon emission and a lot of values that's emerging. To summary, I see representation like before and at, I mean, throughout the period, graph and vector, which is like robust representation, has been important. Now we have emerging representation of image-based, not only image, but it's more like a pattern that we can learn from the using the learning-based method. And now I believe the future direction lies in multimodal representation of the layout, because depending on the representation, what we could understand out of the design also changes, right? And for the objectives, it has started from the space relationship as a constraint, right, in GSP. But then now it's moving towards um, um, to focus on more diversified objectives, which I believe the controlling technique and the representation to cover this varying design objectives could be a very good future direction to focus on. And the last, the control method, as I said, getting it integrated into the existing workflow is something really important, right? Because if you're not doing it, there's no reason to, make it happen. So yeah, so this is a quick summary of what I found out throughout this 50 years of paper. And then before I close out, I kind of want to share what I'm working on to slightly, give some effort to address this issue. So what I'm presenting here is I am preparing a data set to aggregate all the, not only the visual data, but topological and semantic data as a like full data set. And then not only limited to one specific open data, but to comprehend diverging space layout data, because we do have them out there, but their schema is slightly a bit different. So I'm trying to merging them to have a shared schema, not only to 2D, but also I am trying to include it into three-dimensional space layout, because that's really what we're missing. I mean, I didn't cover it today, but we've seen many of the space layout generation applications, but it's mostly focused on single level, which even in this conference building, we have, I don't know, many floors, right? So this is like one of the directions that I'm working on, and I would be happy to discuss about this topic. And this covers what I prepare for the today, and thank you.